Hello guys, welcome back to IT Classroom. I hope you all are doing well. Today we'll be solving IGCSE Computer Science 0478, Paper 1, Variant 2 from Feb-March 2025. This is a 1 hour 45 minutes paper and it is 75 marks. And I'll be showing in detail all the answers to all of the questions in this paper along with explanations which will help you. So if you're new to this channel, do not forget to like, share, and subscribe for more upcoming and helpful content, especially for the upcoming May-June 2025 series. Alright, let's get started on with this paper then. So, okay, the first question that we have here, complete the sentences about number systems. Use the items from the list. Some of the items will not be used, however, we can only use each item once. And this is a 7-mark question, so this I hope it's pretty easy. Let's start. The binary number system is a base dash number system. Now we all know that binary number system, it is a base 2 number system. It is a base 2 number system. Now why do we call it as a base 2 number system? Because they only use two digits, which are 0 and 1. And also the value of the columns, it increases by 2, such as 1, 2, 4, 8, 16. So every time you're multiplying by 2. That's why it's called as base 2. Okay, the smallest binary number that can be represented as an 8-bit binary number, it is basically 0, because if you put all zeros in a binary register, then the binary number being represented by the binary number is 0. On the other hand, the largest binary number that can be represented as an 8-bit binary number, it is basically 255. So basically when you put all ones in the table in the binary register, for example 1, 2, 4, 8, 16, okay, 32, 64, and 128. If you put all of them as ones, the sum of this is basically 255. Do not get this confused with 256. So the numbers can be represented from 0 to 255. That gives you total numbers of 256 because you count the 0 as well. However, 256 itself cannot be represented in an 8-bit binary number. The hexadecimal number system, it is basically a base 16 number system because we use 16 digits, that is from 0 to 9 and A to F. Each hexadecimal digit is equivalent to 4 bits. So basically we know that, for example, let's take the hexadecimal digit of A. A basically represents 10, right? So we know that if you want to write 10, it is going to be 1010. So every single hexadecimal digit is equivalent of 4 bits. The numbers 1 to 9 are used and the number 10 is represented by an A. Okay, and the hexadecimal number system continues up to number 15, which is represented by, now A is 10, B is 11, C is 12, D is 13, E is 14, so F is 15. So therefore the answers are 2, 0 to 55, 16, 4, A and F. I hope this question is clear. Now we'll move on to the second part. Two 8-bit binary numbers are given. Add the two 8-bit binary numbers together using binary addition. Give your answer in binary. Now what is 1 plus 1? It is basically 1, 0. So 1 carry forward in 0. Now 1 plus 1 plus 1 is 1 and 1. 1 plus 0 is basically 1. 1 plus 0, it is 1. 1 plus 1 is 1, 0. Then 1 plus 0 is 1. This is going to be 0, 0 plus 0, and this. So the final answer would be 1010, 1110. Remember that whenever they say show all of your working, and this is a 3-mark question, so really you have 1 mark for the carry forwards that you show and 2 marks for the answer. So make sure you do show the carry numbers. After that, we will move on to part C. The binary addition can result in overflow. Take one box to show the correct definition of overflow in a binary addition. Now an overflow error occurs when the result of the binary addition, or the result of the adding up two numbers, it is greater than the maximum value that can be stored within the register. So we can see that that's obviously C, which says that the answer is too large to represent in the number of bits available. For example, when you add two binary numbers together, which are less than 255, so you could represent them in the 8-bit register. But let's say now you have a binary number which is greater than 255, let's say 300 when you add them together. So that cannot be represented in an 8-bit register. That's why it results in an overflow error. So C is correct. And with this, we have scored 11 marks, which was a pretty decent amount of marks considering the difficulty level of this question, which is pretty low. 11 marks. All right, now let's move on to the next question. Next question says an artist creates an image on a computer. State what is meant by the color depth of an image. Now, basically, the color depth of an image means the number of bits that we use to represent each color. A very simple definition: the number of bits used to represent each color. Number of bits that are used to represent each color. So for example, if you use a color bit of, let's say, 1 bit, that means you can only have two, which is 0 and 1, that is two colors, which is a monochromatic image. If let's say you use a color depth of 4 bits, a 4 bits basically means that you'll have how many numbers now? You'll have 2 raised to 4, which is 2 into 2 is 4, 8 and 16. So you'll have 16 colors. So basically raised whatever the color depth is, 2 to the power of that if the color depth is in bits, and then you would get the number of colors that you can use. So essentially color depth is the number of bits that can be used to represent each color. And the larger the color depth is, the more the number of colors you can represent in your image. Describe the relationship between the resolution of the image and the file size of an image. Now the resolution of the image basically means the total number of pixels in an image. So when you have a higher resolution, you'll have more pixels. And when you have more pixels, you will need more bits to store, because the information about the pixels is stored using bits. So you'll have more bits to store, that leads to larger file size. Very simple. This is what I mean. The higher the resolution, the higher, okay, the higher the resolution. If you have a high resolution, if you have a high resolution image, the more the pixels it has, the more the pixels it has. Okay, that's point number one. More bits will need to be stored. More bits will need to store more bits. So more bits will, okay, where it go? More bits will need to be stored to store information. Why do we need to store more bits? To store information about the pixels, leading to a larger file size. Leading to larger file size. I hope this part is clear. So what I mean over here is that, first of all, the color depth basically means how many bits you use to represent each color, and a high resolution means that you'll have more pixels. And because you need to store the data about each of the pixel using bits, more pixels means that you need to store more bits to insert this information about each of the pixel. And having more bits basically means a larger file size. Next question. The artist compresses the image file before uploading it to her website. The users can then download the image file from her website to print as a poster. The image is compressed using lossless compression. Explain the reasons why the artist chose lossless compression instead of lossy compression to compress the image file. Now, one of the most obvious reasons, considering the scenario, is that you want to provide a high quality image. The artist basically wants to provide a high quality image. But when you choose a lossy compression, it will reduce the quality. So that could be one reason you choose lossless compression over lossy compression. The artist he or she basically they want the artist wants to provide the artist wants to provide the users with the high quality image. The artist wants to provide a user with high quality image of the um okay the artist wants to provide the users with a high quality image. But lossy compression, lossy compression will reduce the quality. Hence, lossless is chosen. Hence, lossless is chosen. On the other hand, we can also say that the image might already be might be small in file size, and the server might have enough space to store the image, so we don't need to actually compress using lossy compression because we do not want a large amount of compression in the image. So we can also say that the image may be small in file size, may be small in file size, and the server might have enough space to store the image. And server might have enough space to store the image. All right, so why would we want to choose lossless compression or lossy compression is because first of all you want to provide a user with a high quality image, but if you choose lossy it will reduce the quality. Moreover, the image might already be small in file size, so you do not need to go for lossy compression, and the server might have enough space, so why do you actually need to compress a lot? Okay. Identify one lossless method of compressing an image. Describe a chosen method. Now, the only method for lossless compression of an image that is covered in the IGCSE syllabus is basically run length encoding. Now, run length encoding can be applied to text and as well as images. And what essentially happens is that if you have, let's say, a repeating series of the same color, you replace that with that color and the number of times it occurs. So what does it do is that RLE compresses RLE compresses an image by storing storing consecutive pixels of the same color as the color and the number of repetitions as the color and the number of repetitions. So essentially what is happening is that they're asking us what is meant by run length encoding. Run length encoding basically it compresses a file. How does run length encoding compress a file is that it stores, if you have a consecutive series of pixels just repeating, so it's red for let's say 10 blocks, you can replace that by writing just red for the next 10 blocks, and this is how you essentially compress a file. All right, now it says that the artist emails the image file to her friends. Explain how a file is broken down into packets and transmitted over a network. So basically we know that over a network it is through packet switching. So first of all what happens is that the data is going to be split. Data is split into equally sized packets. The data is split into equally sized packets. So that's point number one. And we also know that the packets, basically for every single data packet that you have, it has a header, it has a payload, that is the data itself, and it also has a trailer. So the data, the data, it is in the payload of the packet. The data is the payload. The data is the payload. The data is the payload of the packet. And also every packet basically it has a header with the data, which is, so the data is the payload of the packet has a trailer, the packet has a trailer along with a header. Now, why do we need the header for? To store, let's say, the destination IP address and the order of packets. To store destination destination IP address, comma, the order of packets, etc. Explain how a file is broken down into packets and transmitted over a network. So what happens is that the data, like when you want to send a data over a network, the data will be split into equally sized packets, and then in the packet, a packet basically consists of three main parts, which are the header, the payload, and the trailer. So the header basically has the IP address of the sender, IP address of the receiver, the total number of packets, the order of this packet. The payload, it has the data itself, and the trailer, it basically has a method to identify the end of the data, along with sometimes cyclic redundancy checks as well. Now we have understood that how we split the packets. Now how does it work? So basically we have routers. Routers. What do routers do is that they send the directs each packet towards its destination in the most efficient route. Okay, routers, they direct each packet. The routers direct each packet towards its destination by opting for the most efficient route. For the most efficient route. Now, because routers select a route for each packet, the packets can essentially take different routes. The packets can take different routes and might arrive out of order. And might arrive out of order. Once the last packet has been arrived, once the last packet once the last packet has arrived, they are reordered or reorganized. Reordered, okay, with no, they're reordered using the data in the header. Let me summarize this five marker for you. Basically, first of all, you split the data into equally sized packets. The packets, it has a header, a payload, as well as a trailer. Now you have routers. What does it do is that they direct the packets towards the destination along on the most efficient route. Now because the route is taken differently, basically packets all of the packets can take different routes to destination, and therefore they may arrive out of order than the order that is sent in. Once all of the packets arrive, then basically they are reorganized using the data in the header, because the header consists of the order of the packets as well. All right. Now the next question says the packets can use many different types of data transmission to travel. Completely enter the diagram to show the difference between serial full duplex transmission between two computers and parallel simplex transmission between two computers. Now a serial basically means that you have one bit of data is transmitted at a time along one wire. Okay, and a full duplex basically means that data can be transmitted in both directions. So you're going to have one wire which can transmit like this, and you have one wire which is transmitted like this. So basically, we can write a short description over here that we're only using one wire, and because it is full duplex, both data can be transmitted both ways. One wire data can be transmitted in both directions at the same time. in both directions at the same time. So basically, what's going to happen is that from computer 1 to computer 2, there's only going to be one wire, and the data can be transmitted in both directions at the same time. On the other hand, parallel simplex transmission. Now, how does parallel simplex transmission work? Is that parallel basically means you have more than one wire, so you're going to have multiple wires. But simplex basically means the data can be transmitted in one direction only. So you have data transmitted, data transmitted using multiple wires, but in one direction only. But in one direction only. Again, simplex serial data transfer basically means that one bit of data is transferred at a time using one wire channel. That's why I'm only using one wire in the first one. On the other hand, a parallel basically means multiple bits of data transferred at a time using multiple wires. That's using multiple wires. Full duplex basically means the data can be transferred in both directions at the same time, whereas simplex basically means only one direction, and there's half duplex, which means both directions but not at the same time. At the particular time, you can only transfer in one direction, but overall, it supports both way as well. Now, moving on to the next question, it says a computer has a CPU, memory, and a secondary storage. The computer has a von Neumann architecture. Circle three registers that are found in the von Neumann architecture. So we know that there are a lot of registers in the von Neumann architecture, including the accumulator, the CIR, current instruction register, MAR, MDR, PC, etc. So first one I can see over here is the accumulator. I know that is found over there. Second one would be a current instruction register that stores the current instruction that's being decoded or executed. And we also have a program counter over here that stores the memory address of the next instruction to be loaded in the memory. I hope this is clear. None of the other registers are actually in a part of the von Neumann architecture. State the purpose of a CPU in the computer. Now, what essentially the CPU does is that it executes and processes instructions and data so that we can produce an output. It executes, and we can say that execute or process the same thing. Execute or process instructions and data. And why do we want to execute or process instructions and data? So that to produce an output. All right. I hope this part is clear as well. The main purpose of having a CPU is that so they can execute and we can process and execute, basically execute the instructions and process the data so they can produce an output. A computer A, it has a 2.1 GHz quad-core processor, whereas a computer B, it has a 2.5 GHz dual-core processor, and a computer C has a 5.2 GHz single-core processor. Identify which computer is most likely to execute instructions simultaneously. Now, obviously, you guys might be confused between computer A and computer C. But when it says more instructions simultaneously, you'll have to go with computer A because it has 4 cores, quad core. The answer would be computer A. Now, the explanation is that a core basically refers to how many instructions you can process simultaneously. So computer A, it will be able to process 4 instructions simultaneously, whereas computer C, it will be able to process only 1 instruction simultaneously. So we're gonna say that computer A has 4 cores, 4 cores, and we also know that every single core, each core can execute 1 instruction at a time. Each core can execute 1 instruction at a time. At a time. Hence, 4 cores allow 4 instructions to be simultaneously allow 4 instructions to be simultaneously executed. Again, The number of cores means that how many instructions that you can process simultaneously. So a quad-core computer, because every core processes one instruction at a time, 4 cores means that you can process 4 instructions simultaneously. Explain why computer C, which has a 5.2 GHz single-core processor, can execute more instructions per second than computer B, which is a 2.5 GHz dual-core processor. Alright. Now basically because we see that the computer C, it has a 5.2 GHz processor, 5.2, whereas this is a 2.5 GHz dual core processor. So even when you consider the effects of dual core, for example, 2.5 GHz, you multiply that by 2, it will be only 5 GHz, whereas this is 5.2 GHz. So obviously computer C can execute more instructions. And why can it do that? Because it has a high clock speed, so more you'll have more fetch execute cycles per second, and hence you'll execute more instructions per second. Okay. Basically, we're gonna say that computer C, computer C has a higher clock speed, which is 5.2 gigahertz, a higher clock speed. And a clock speed basically refers to how many fetch execute cycles are there per second. Hence, more FDE cycles run per second, more FD cycle runs per second. Hence, more instructions can be executed per second. More FD cycles run per second, hence more instructions can be executed per second. More instructions executed per second. Alright, I hope this is clear. Explain why computer C can process more instructions. First of all, why was computer A able to execute more instructions? Because it has 4 cores and each core can perform one instruction at a time. So 4 cores means 4 instructions processed simultaneously. Now, why can computer C execute more instructions than computer B? Because a computer C, as you can see, it has a high clock speed, so there'll be more fetch execute cycles in a second, so more instructions executed per second. After that, all 3 computers have the same instruction set. Define the term instruction set. So basically, you know that an instruction consists of an opcode and an operand. Opcode basically refers to the instruction itself, and operand refers to what data does it have to act upon. So the instruction set, it basically contains all the opcodes that can be processed by the CPU. So we're gonna say that instruction set is a list of commands. It is essentially a list of commands that can be processed by the CPU, that can be processed by the CPU. The instruction set is nothing but it's just a list of all the commands that can be processed by the CPU. So all the instructions, the opcodes of all the instructions, they will lie in the instruction set so that the computer can process it. Alright. Next up, we have an automated teller machine, which is the ATM, is a device where a person inserts their bank card and can request to withdraw money. The ATM also allows the person to check how much money they have in the bank account. A sensor is used to detect when a person stands within 1 meter of the ATM. When a person is detected, a welcome message is displayed. Identify an appropriate sensor for this. For this, I would basically, let's say, use infrared sensor. You can use infrared sensor to detect if the person is there. Sometimes also motion sensor might be alright if you detect movement, that means a person is there as well. But I prefer infrared is much more better for detecting a certain object. Describe the role of the microprocessor in detecting the person. Now, what happens is that the sensors, they will receive the digital data continually from the sensors. The microprocessor, it will receive digital data continually from the sensor. And then they use the sensor data to calculate the distance to the person identified. If the distance is less than 1 meters, it basically compares the calculator to the sensor data. That means the data, which is the digital data sent to the sensor, is compared to the stored data, that is that 1 meter. If the data is less than or equal to 1 meter, then you send an output or send a signal to display the welcome message on the screen. I guess this will be more clear once I write down the answer over here. So what's going to happen is the microprocessor, it receives digital data. Now, it's very important to write the term digital here because the computer cannot actually understand analog data. So, microprocessor receives digital data continuously from the sensors. When this term is important because sensors send the data at all times, regardless whether it has changed or no, from the sensor. Now, it then uses the sensor data to calculate the distance to the person. It uses the sensor data to calculate the distance to the person. The distance value is compared to the stored value, which is 1 meter. If the distance is less than or equal to 1 meter, microprocessor sends a signal to display the welcome message. So the question here was that how do we understand the role of the microprocessor in detecting the person? It's very easy. Basically, microprocessor, what happens is that it receives the digital data continually from the sensor. The first thing you need to understand is that microprocessor, it receives the digital data continually from the sensor. After that, it uses the sensor data to calculate the distance to the person, then compares to the stored value of 1 meter. If the distance or the calculated value of the distance is less than 1 meter, then it sends a signal to display the welcome message. Describe the features of the ATM that is identified as an embedded system. So the question they're asking us over here is that what makes this an embedded system? We can now embedded systems are a combination of hardware and software that are designed for one specific function. So one reason why an ATM is an embedded system because it is a special purpose device, or we can it has a dedicated function, or it's a special purpose device. And moreover, it also means that we can also say that it has a dedicated hardware. So ATM is an embedded system. ATM ATM is an embedded system because it has a dedicated function. It is not a general purpose device and it has a dedicated function. It has a dedicated function, not general purpose device. And also it has dedicated hardware and also dedicated hardware. The main reason why we call ATM as an embedded system is because it has a dedicated function which is withdraw money or check the balance, and also it has a dedicated hardware which can only be used for ATM. For none, it cannot be used for other purposes. The ATM has a touchscreen and a keypad. The ATM maybe need to be used by people who are unable to see. Identify one other input device and another output device that can be built into the ATM to help people who are unable to see. Now, an input device for them could be a microphone. So basically, what will happen is that they can send out like voice instructions regarding my card number or my PIN, etc. So there could be a microphone. And for the output, I would say that there should be a speaker so that the computer or the system can communicate with the people who are not able to see. It's a pretty easy thing to understand. After that, we're on question number 5. The question number 5 says the computer is connected to a network. The computer has a network interface card and it also has a MAC address, which is a media access control address. One purpose of the NIC is to provide a computer with a MAC address. Describe the other purposes of the NIC. Now, NIC is something which stands for Network Interface Card. And what is the purpose? The question they're asking over here is that what is the purpose of a network interface card, right? What is the purpose of a network interface card apart from assigning the computer with a MAC address? So one of the other purposes of NIC is that it receives the data from the network, and that data, it is analog and it converts it into the form which is understood by the computer, and also allows to convert the data from the computer to a form which can be transmitted over the network. Okay, so that's going to be the two purposes. NIC, it receives data, it receives data from a network and converts into form understood by the computer, which is basically digital form, and converts to a form understood by the network. It also converts data from the computer, data from the computer to a form that could be transmitted over a network, that could be transmitted over a network. So essential thing to understand here, describe what's the purpose of something which is called as a NIC. NIC stands for Network Interface Card, and the main purpose is that one of the main purposes is to provide the computer the MAC address. Another purpose is that it receives the data which has been transmitted over the network, which is an analog form, and convert into a digital form which converts with the computer. It also takes digital form and converts into analog form. Identify three characteristics of MAC addresses. Now, the first characteristic of MAC address is that it is always represented in hexadecimal, and we also know that the numbers in a MAC address, they're separated by colons. So numbers separated by colons. Additionally, it has, you can also say that it has sets of two-digit hex numbers. Sets of two-digit hex numbers. Right. Just give me a minute. Yep. All right. So we have got this. Basically, we all know that a MAC address, it consists of six groups of two hexadecimal numbers each. The first three being for the manufacturer identifier, and second three, the last three groups are for the device identification. And that's how we essentially get this answer. That is, what is a MAC address? Right. I hope this question is clear, and I hope that all the previous questions have been answered till now. They are clear as well. Now we'll move on. We basically, for example, a MAC address, the first half is called as the manufacturer of the device. The second half is the serial number of the device. Okay. There could be another point that you can add on. It has six groups of digits. Fourth point, six groups of digits. So the first point is that it is represented in hexadecimal. The numbers in the groups, basically, they are separated by colons. There are six groups, and each group has two hexadecimal digits each. The first half is the manufacturer ID, and the second half is the serial number of the device. After that, it says the network allocates an internet protocol address to the computer. Take one box to identify a valid IPv4 address. Now, the first one is obviously wrong because IPv4 addresses, they use dots, they don't actually use colons. So this is incorrect. Second one, 2FF is basically outside of the boundary of the numbers that can be in one group. That is basically, it has to be from 0 to 255. So it can't be 2FF. 3, 162, 74, 3. This is correct because All of the numbers are between 0 to 255. If you use the last one, it has 257, which is again outside the boundary of 255. That is why it is incorrect. And I hope this part is clear as well, that how have you gotten the answer as C. Now we'll move on to, it says identify the device and network that can automatically assign an IP address to the computer each time the computer connects to the network. That is nothing but a router. A router is a device or network that basically assigns an IP address whenever you connect to the computer. All right, the next one is define the term World Wide Web. The World Wide Web, again, I think it's a pretty easy definition. The World Wide Web, what does it stand for? So it refers to a collection of websites. It refers to a collection of websites and web pages, collection of websites and web pages that are accessed using the nothing but the internet, that are accessed using the internet. So the question asking here is that what is the definition of a World Wide Web? The World Wide Web is nothing but a collection of all the websites and web pages that are essentially accessed using the internet. Okay. And now we'll move on to the next part, which says that the URL for a website includes the protocol HTTPS. Explain how HTTPS makes the transmission of the data secure. Now, this is an important question. Basically, HTTPS, what it does is that it uses SSL, which is Secure Socket Layer, or TSL, Transport Security Layer. And this is how it works. HTTPS, it uses first things SSL/TSL protocols during transmission of data, during data transmission. It also encrypts the data. It also encrypts the data using asymmetric encryption. It also encrypts the data using asymmetric encryption. So the data, now when you say asymmetric encryption, what happens is that when you encrypt the data, it will be encrypted to this web server's public key, but the data can only be decrypted by the web server's private key. Hence, the data can only be decrypted by the web server's private key. Now, what happens to asymmetric encryption is that the data is encrypted using web server's public key and decrypted using web server's private key. All right, I hope this part is clear. Now, I'm going to explain this very shortly. Explain how HTTPS makes the transmission of data secure. One thing that HTTPS uses is the SSL, which is a secure socket layer, or the TSL. And both of these help to make the data much more secure. It also, the transmission of data, HTTPS encrypts the data using asymmetric encryption, which is basically that you use two different keys for the basic encryption and decryption. When you encrypt the data, you encrypt it using the web server's public key. And when you decrypt the data, it is decrypted using the web server's private key and can only be decrypted by the web server. So that no other person, because no one else has the web server's private key, so only the web server can decrypt the data, making it much more secure. The protocol is one part of the URL, give two others part of a URL. So a part of a URL, there are many different parts of a URL. It has the protocol, which means the HTTPS. Then you go on, you also have something which is called as a domain name. Domain name is like the main name of the website. For example, it's wikipedia.com or google.com, etc. And after that, it also says, we can also something say as file name. So file name, because a website, it has a lot of web pages, The file name corresponds to what particular web page you are at. So for example, you are on a web page of, let's say, Formula One on the site of Wikipedia. So your domain name would probably be Wikipedia and the file name would probably be Formula One. Okay, I hope that's clear. Now let's move on to the next part. It says the search engine, it uses artificial intelligence to identify the most relevant web pages for the user. One characteristic of the ability of AI is the ability to run. Identify three of the characteristics of AI. First of all, we know that along with the ability to learn, it also has the ability to reason. Ability to reason. So basically, reason means that it can provide an explanation for whatever results that it provides, or for a particular thing that we ask, it can provide an explanation for that. Second thing, we also know that it has an ability to adopt. So along as AI is being used, it learns from the user and then it adopts its responses or its rules so that next time it is more correct, more accurate, or basically it uses a feedback from the user to improve its response. And we can also say that it has a collection of data which is basically used where it searches on collection of data along with the rules for the data, along with the rules for the data. So the three main characteristics of AI is that it can learn, it can reason, it can adopt, and also it has a massive collection of data. It also stores the rules for making inference on the data. The search engine uses machine learning. Explain how machine learning is used by the search engine. Okay. Now, basically, whenever I talk about AI in IGCSE, there are two different systems: expert systems and machine learning. Expert systems, what do they do is that they already provide us a lot of data and they make inference on that data. For example, for a patient, so you provide a lot of data about, let's say, symptoms, disorders, etc. The patient just inputs their, let's say, condition or what are they facing, and then it tries to provide what could be a corresponding issue they're facing along with solutions. On the other hand, another thing is machine learning. So in machine learning, you train the AI model with examples so that it can respond to unknown models which are similar but not have not been shown to the AI model before. And every time it sees a new model, it actually improves the understanding and gets more and more better with responses. So we can say that machine learning changes its data and rules. Machine learning changes its data and rules according to the feedback or the results. According to the feedback, machine learning, it changes the data rules according to the feedback or the results. Now, an example here could be that if the result does not provide a suitable response and is recorded, and next time the result will be changed. An example is if result does not provide suitable response, it is recorded. You will record this that it does not provide suitable response. It is recorded, and next time it will be changed. And next time it is changed. It also allows supervised or unsupervised learning, supervised slash unsupervised learning. So basically, a supervised learning means that the engineers they do make the AI model train using some experimental data, whereas unsupervised basically means that it learns when it's actually working with the users. All right, and also when you're talking about search engines, we can also mention one more thing is that it uses ranking algorithms. It uses ranking algorithms to decide which result appears first? Which result appears first? All right, now let's be clear about this. We understood the first part, which is the AI's ability to learn, reason, adopt, along with the collection of data with the rules for the data. Machine learning, what it does is that it changes the rules in the data that it has according to whatever the feedback that is provided by the user or sometimes the result. For example, you see that the result does not provide a suitable response, and then it will understand that yes, my result has not provided a suitable response. So next time it will try to change the result or not provide the same thing. It also allows supervised or unsupervised learning. Supervised means using AI engineers, and unsupervised basically means that it learns while it is working. The third part also uses ranking algorithms, which is specific to search engine category that you often see which results appear up first. So uses ranking algorithms to decide which results appear first. That is, which result or which web page would match closely to the user's search, and hence that's going to appear first. After that, it says that programs can be written in high-level languages or low-level languages. Machine learning is a type of low-level language. Identify another type of low-level language that's obviously nothing but an assembly language. Assembly language. And identify the translator that is needed for the type of the low-level language you have identified. For this assembly language, you need a assembler to translate it into machine code. All right, I hope this is clear. Now it says that a high-level language can be translated into a low-level language using a compiler or an interpreter. Describe the advantages of using an interpreter instead of a compiler during a software. So basically, in a compile interpreter, what happened in a compiler, what happened translates the entire code and then it runs it. It produces executable file as well. And if there's an error, it does not run it and rather produces a report. On the other hand, interpreter, it runs the code like statement. One statement you translated, you execute, and then you go to the next statement. And whenever the error occurs, the translator stops. So the previous code, like all the code before the error, actually runs. So when it stops, you can actually make real-time changes, and then it will still continue to work. You don't need to start from again and recompile the code. And we also know that because interpreter it runs the code, each statement is translated line by line. You can test a particular section of a code without having the entire code complete or accurate. Okay, so we can say that an interpreter, in an interpreter, each statement is translated and executed. You translate like every single statement. Each statement is translated and executed. You translate a statement, execute a statement before the next one. Translate and execute the statement before the next one. And whenever there's an error occurs, when an error occurs, the translator it stops over there and like it notifies us that an error has occurred. Translator stops, allowing the error allowing the error to be corrected in real time. Allowing the error to be corrected in real time. Also, after correcting, after you have corrected the error, the program continues from where it stopped. The program continues from where it stopped and does not need to be retranslated, unlike the compiler, and does not need retranslation, which is in a compiler. In a compiler, interpreter allows to test. Interpreter allows you to test sections of code without without program being complete. without the program being complete. All right, let me explain this to you. So basically, in an interpreter, you execute, you translate and execute a statement, then you move on to the next one. So that means whenever there's an error that has occurred, it will stop over there. It allows us to correct the error and then continue where it is. However, if you use a compiler, it would not run the program at all. And if you make a certain change, that means if you make a certain change in the program which has been compiled, then you would need to read, translate, and recompile the entire program. In an interpreter, because every statement is translated and run like one by one, you can test like let's say the top 10 lines of the code and without the bottom 10 being complete. They might still be incomplete and stuff, not valid, and it will still run. Whereas a compiler, it would require the entire program to be complete. This is why interpreters use when you're maintaining or when you're building the program, when you're coding or testing, whereas compiler would be used when you want to produce an executable file for the users when your program is completed. IDEs provide translators. Identify three other common features of an IDE. Now, this is my favorite question because it's pretty easy to score, and the favorite answer to this question is pretty printing. Now, if you have used programming softwares before or coding, you would often notice that they color code the words differently, which makes it easy to identify. So, pretty printing is one option. Second option is auto completing. So, basically, sometimes they will suggest you that you want to complete, they try to understand what you're typing out and then they suggest that they want to complete this with this, which is useful as well. Along with that, they provide you with a code editor. So code editor basically means that you don't need a separate program to write, then write the code, edit the code, and a separate program to run the code. They are integrated together, so that which makes it much more easier. They also provide you with autocorrect. So sometimes when you make error syntax errors, it notifies you and then you can correct your error immediately during that program. It also provides you with collapse or expand blocks. So basically, for example, you've written down an entire function or a procedure, and you don't actually need that. So it allows you to completely collapse or expand that whenever required, which makes it much more better to view the program overall. And you also have something which is called as breakpoints. So these are essentially your debugging tools, which means that you can set a breakpoint that I want to stop the program from running after this line. I want to only run the program over till this line. Okay, there are several others and you will find that list in the marking scheme, but you can use these are the easiest ones to remember. All right, so I guess by doing this question we have reached the end of this paper. I hope this video was really helpful to you guys, and I hope I have cleared any questions that you have. Apart from that, if you have any more questions or doubts, please do post them in the comments below and I will try to respond to them as soon as possible. Stay tuned for more helpful videos. If you guys have any video suggestions or topic suggestions that you would want me to make, please do post it down below. I will be very grateful for you guys so that I don't have to think about a lot of video topics. And don't forget to like, share, and subscribe to my channel for more upcoming content, again, as for the May June 2025 series. I'll see you guys in the next video. Till then, bye, take care, and good luck.